Okay, back again, this time with an example of an angled projectile. All right. So here is where we're going to have a projectile that's launched into the air at a specific angle, and we're going to see how that's going to change um, our answers from what we did with horizontal projectiles. All right, so here we have a soccer player that kicks a ball into the air with a velocity of 12.5 meters per second at an angle of 60 degrees. All right. Now, before I start thinking about what the different parts of this problem are actually asking me, okay, what I really want to do is get a head start on my organization. So I'm going to start with a picture. I know that a soccer player is going to kick that ball, all right? So I'm going to start by drawing the ground, all right? And I have my soccer ball that's going to go up into the air. And it says here that it's going to hit at an angle of 60 degrees. And so that's where my angle of 60 degrees is going to be. And I know that he's kicking it with a velocity of 12.5 meters per second. Now what's going to happen to this ball? It's going to go up into the air, and it's going to come back down, but it's also going to move side to side as it does that, all right? And so as it does that, it's going to follow a nice parabola to get back to the ground. And so this is the trajectory of our soccer ball, all right? How do I know that? Because that's what happens when you kick things in the air, all right? So this is my starting point. I have my picture, all right? But the next thing that I want to do is a step that we did with horizontal projectiles, but didn't really have to do much calculation for. What we want to do is we want to find the vertical and horizontal components of our initial velocity here. All right. So we're going to find those components. This is my horizontal component. This is my vertical component. All right. Now, if we look back to our notes, we're going to see that we calculate those with these two equations. All right. So we're going to take our velocity of 12.5 meters per second and multiply it by the cosine and sine of 60 degrees to get our two components. So I take my 12.5 meters per second times the cosine of my 60 degrees, and then I'm going to do my 12.5 meters per second times the sine of my 60 degrees. Now this is going to give me my two components of my velocities, all right? So when I punch these in, I'm going to get two answers. My first answer for the horizontal component is 6.25 meters per second. And when I punch this into my calculator for the vertical component, then I'm going to get 10.83 meters per second. All right, so this is my horizontal and vertical components of my velocities. All right, I'm just going to shorten this a little bit so that I have more room to work. But that is how it is solved. All right, so 6.25 meters per second and 10.83 meters per second. All right, so now I want to start thinking about my vertical and my horizontal directions. All right, now how long the ball is in the air is going to be completely determined by how high it goes up into the air. So the maximum height that it reaches, that's going to come from the initial velocity that is kicked at in the vertical direction. So when we're talking about time, the time is limited by the velocity it's kicked with and the height that it reaches. All right, and it's all vertical stuff. So I'm going to look at the vertical direction because I think that's going to get me the answer that I'm looking for. All right, so my initial vertical velocity, I calculated over to the left. That's 10.83 meters per second. All right, that's a vertical thing. Next thing I know, I also know negative 9.81 meters per second squared for my acceleration. Now, if I want to solve for time, which is how long the ball is in the air, I'm going to need another piece of information. And this is where we're going to have to dig deep conceptually, all right? So conceptually speaking, we know a few things about this, and they can all be used to help us solve for this time. Now, I think the easiest, all right, is to think about some of the symmetry that we know with vertical velocities. So if I throw an object straight up into the air, it's going to go up, it's going to reach its maximum height, and it's going to come back down. When it reaches the same height, like this soccer ball is doing, all right, so this is my starting point, this is my ending point. When it reaches that same height, we know that the velocity is going to be equal and opposite to the velocity at the same height there. So I know that if my starting velocity here is 10.83 meters per second, then at the same height when it's gone this way back down, it's going to have a velocity of negative 10.83 meters per second. Ha ha! So as long as it comes back to the same height, it's going to have an equal magnitude, 10.83, but opposite direction. So it'll be negative. All right. So this is enough information to be able to solve for time here. So I'll use this equation, substitute my values. All right, and solve for t. And so when I get that value, I'm going to get 2.21 seconds. All right, so that's one approach. There are other approaches here. So maybe I didn't use the final velocity. We can also think about this as having a vertical displacement, delta y, of 0, because it starts and ends at the same height. So because my ending point, which is here, and my starting point, which is here, have the same height, then delta y could also be 0. And that's another way to solve for this time. All right, so that could be our third given that could help us find our unknown time. All right, so there's our first step. Okay, we found the total time that the ball was in the air, and that's going to help us with part B, which is asking how far the ball actually goes. All right, so that means what is this horizontal displacement? So I'm going to clear things out here for a second. All right, part B is asking us this new question, how far does it go, which is displacement, right? So let's think about this. It's a horizontal thing. All right. So we're looking at all horizontal stuff. All right. Now our starting and ending points are the same here still. Like here's my start, here's my end. And the displacement between there, delta x, that's what we're looking for. So delta x is my unknown. Now one of my givens is my horizontal velocity. I calculated it earlier of 6.25 meters per second. So all I need is the time to be able to solve for my displacement. All right, so we're looking at this. How do I know this time? Well, I know that time. I just calculated it. That was the hang time. It takes 2.21 seconds to get from my starting point where it's kicked to the ending point where it hits the ground again. All right, so I can substitute these values into my equation. I'm always using the same equation for horizontal direction. All right, my velocity is 6.25 meters per second. My displacement is what I'm looking for. My time is 2.21 seconds. And I get a horizontal displacement of 13.81 meters. So from the point where it's kicked to the point where it lands, it's 13.81 meters along the ground. That's just the horizontal displacement. So this isn't measuring how far it went through the air. It's measuring just the horizontal part, just along the ground between the starting and ending points. All right. So the final question is asking us about the maximum height. All right. So the last part is all about the maximum height. Now we have to be careful here because when we're talking about the maximum height, we're changing some of the things that we think we know. All right, I'm going to keep my picture there. We're going to start answering C. And see, the problem is now the final velocity isn't negative at 10.83 anymore because my ending point isn't here at the end. It's actually up here at the very top of my parabola. So all the numbers that I calculated so far, they were all for having an ending point all the way at the end of that parabola. So things are going to be different. Final velocity will be different. Displacement will be different. And what we're actually looking here for the maximum height is to find that vertical displacement between the place where it's kicked and the place where it ends. Well, one thing that I know is that the vertical velocity is 0 at the maximum height. So that's something that I know to be true, is that the vertical velocity is 0 meters per second at the maximum height. All right. So do we have enough information here? Let's just take a look. So in the vertical direction, we have an initial velocity in the y direction. That's 10.83 meters per second. We have a final velocity in the y direction. That is 0 meters per second. We have an acceleration of negative 9.81 meters per second squared. And we are looking for the vertical displacement. So the vertical displacement from start to the very peak there, where the velocity is 0 meters per second, that's going to be the same thing as our maximum height. All right? So we can use this equation to solve for the vertical displacement. All right? Okay, and we'll go ahead and solve for the vertical displacement. And we're going to get 5.98 meters. Actually, I don't think I wrote the answer to B a little bit earlier, but the answer to B was going to be 13. Oh, no, we didn't. It was 13.81. All right. So there we go. So it reaches a maximum height of 5.98 meters. It goes a total distance along the ground of 13.81 meters. And we know that it's in the air for an amount of time of 2.21 seconds. All right. There you go.